Welcome back, Apologia 8th grade physical science, week 22, day 4, textbook pages 380 to 381, and notebook page 316 and 317. There are many marvelous facets of the eye, but we will concentrate on one, the way it focuses light. Remember, the reason we see things is that light reflects off of them and then enters our eyes. Our eyes then detect the light and send signals to the brain, which forms an image in our mind. We will study how the eye handles light, but before we do that, we should discuss how lenses work because our eyes have a truly amazing lens. The fact that light rays tend to bend when they travel through transparent objects can be quite useful. For example, consider a light ray traveling through the object in this figure 10.37, which is made of glass. When the ray strikes the transparent object, it will be refracted, and this just means that the light is going to bend toward a line perpendicular to the surface at the point of contact. So here we go. Here's our incident light ray. It's coming in. Light is going to, the line perpendicular to the surface at the point is right here. So the incident light ray will bend here. Now, the light ray will travel through the glass along the path indicated in figure 10.37. At some point, however, the light ray will reach the edge of the glass object and exit. At that point, the substance through which the light is traveling will change. Thus, the light will be refracted again. Since light travels faster in air than it does glass, the refracted light ray is bent away from the perpendicular. The result is pictured in figure 10.38. So here we go. Here's what we first looked at. And now here is the result of it. This is what they're talking about as it exits this surface. If you were to do this for several light rays traveling horizontally toward the object, you would have what is shown in figure 10.38b. It turns out that a transparent object shaped like the ones in 10.37 and 10.38 will always focus horizontally traveling light rays through a single point called the focal point. So what it's saying is these horizontally traveling rays will always be focused right here to a focal point. We call such an object a converging lens because it makes all horizontal light rays converge to a single point. You should know that the converging lens drawn in this figure above are drawn very wide to easily illustrate how the light ray refracts twice as it travels through the lens. Generally, converging lenses are much thinner than what it is shown. All right. If I change the situation a little bit, I get a completely different result. Suppose I have a glass object shaped like that in figure 10.39. So here we have a concave lens instead of a convex lens. When light rays hit this object, refraction causes a completely different situation from what I got with the converging lens. This kind of lens, called a diverging lens, bends light rays outward, causing them to diverge away from one another. Once again, please realize that most diverging lenses are much thinner than what I have pictured here. Converging lenses and diverging lenses each have their applications. Notice the difference between converging and diverging lenses. The sides of a converging lens are curved outward. As a result, we say converging lenses have a convex shape. So going outward, these would be convex. The sides of a diverging lens going in, they are curved inward. We call this a concave shape. This should tell you something. Lenses work because of their curvature. If the curvature changes, the way the lens works changes. In fact, the type of curvature, concave or convex, is not the only thing that affects the way a lens works. The amount of curvature also plays a role. Try to figure out how the amount of curvature plays a role by answering this on your own question. All right, consider these two lenses. They are converging lenses and they are convex shape. Which one focuses light rays closest to the lens? All right. So lenses work because of their curvature. The more curvature they have, the more they will do their job. So this one here, lens B, is going to focus it closer than lens A. Lens A will focus it farther away than lens B. All right, just to be a little bit more helpful, Venn diagram on page 317. Venn diagrams are used to compare and contrast. List the differences between the two terms in the outer circles and the similarities, or what the terms have in common, in the middle section. Use the Venn diagram to describe the similarities and differences of converging and diverging lenses. So I went and put together the list. Specifically to converging lens, they will always focus horizontally, traveling light into a single point or a focal point, and they are convex shape. Exclusively to a diverging lens, they will bend light rays outward, and they are a concave shape. And then in the inner circle, where they're overlapping the similarities, both lenses, light rays bend when they travel through transparent objects, and lenses work because of their curvature.